Hi, in this video we will talk about how to write expressions without the rational exponents using radicals. We will also talk about how to make a negative exponent positive. So to begin with, rational exponents, when you see the word rational, just think about a fraction. So now instead of just having an exponent, we've got a fraction as an exponent, and they are linked hand in hand with radicals. When I look at the exponent, the denominator tells me what root I'm taking, and the numerator tells me the power I'm raising my base to. Okay, so this is my power. In other words, if I look at the denominator here, it's a 3, so that tells me I'm taking the third root. And then the numerator tells me I'm taking 8 to the first power, so I'm taking the third root of 8. Now, we can further evaluate that because we know the third root of 8 is equal to 2, because 2 times 2 times 2 is equal to 8. Similarly, if I have a cubed b cubed raised to the 1/5 power, again, my denominator tells me what root I'm taking. So I'm going to take the fifth root, and the numerator tells me I'm raising a cubed b cubed to the first. So what I'm going to end up underneath my radical, called the radicand, is a cubed b cubed. Last, let's look at 49 raised to the 3/2 power. Again, the 2 tells me I'm taking a square root. Whenever I take a square root, I do not write any number here as my index, okay? So if there's nothing here, I know I'm taking a square root. And now I'm going to raise 49 to the third power. I can use my calculator to calculate 49 to the third, and I come up with 117,649. And now I can further use my calculator to see if that is what the square root of that would be. And using my calculator, I see that that is equal to 343. Now, when we talked about exponents before, we talked a lot about how it's important to keep our exponents positive. And when we deal with rational exponents or fraction exponents, the same thing holds true. All right, recall before that the way I can make an exponent positive, suppose I had a to the -2, is to simply move it into the denominator. So to make my exponent positive, I just stick a squared underneath 1. And whenever I cross the border, so to speak, I change the sign on my exponent. It works the other way too. If I have 1 over a to the -2, I can change that to a positive exponent by moving this up, and it becomes a squared. So when I want to make my exponents positive and I have a fraction, it's going to work the same way. Here I have 3 to the first, so I'm not really going to do anything with that, but I have x to the -1/4. So the way I'm going to make that exponent positive is by simply moving it into the denominator, and it becomes x to the +1/4. In the second example, I have 5xy raised to the -5/6 power. The way I'm going to make that exponent positive is simply by moving the entire thing into the denominator. Notice that the only thing that's changing is the sign on my exponent. So I still have 5xy raised to the 5/6 power, but now it's a positive 5/6. In my last example, I want to first write everything using exponents. So I have 6a, but in my denominator, I have the fourth root of b. So similar to what we did above, I can go the other way. b is raised to the first power, so that's going to give me the numerator of my exponent, 1, and I'm taking the fourth root. So my denominator of my exponent is going to be 4. And notice that all my exponents in this case, I've got 6a over b to the 1/4 are positive, so I've written everything as positive exponents. So I hope this starts to get at how we can take a rational exponent, or in other words, a fraction, and go to a radical and vice versa. And when I need to change the sign on my exponent, I simply either move it into the denominator or up to the numerator.